Okay, so last time we learned this new, exciting, kind of an organized, do you agree it's kind of an elegant way of representing your computation for simplex algorithm for the LP method, all right? So what we will do today will be, we'll go through maybe 2 examples, computing it by hand to get really comfortable with this procedure, all right, before we call for help with the computer. All right, so what I will do, we'll do 2 examples. So let's just start with an example. So example 1. Okay. Maximize. Okay. So I have the following LP problem. Oh, I should have started on the left. Okay, it's okay. 3x1 plus 2x2 less than 60. Okay, let's say I have this problem, linear programming, and you see that it's not even in standard form. Okay, this will be a favorable example of converting this into a standard form, and it will actually be advantageous having this type of problem. So we'll see. So do we still remember how to convert such a problem into a standard form? Do you remember? Was it the last homework? What do we have to do? We need to add something called slack variables. Is that right? So for each inequality, you have to add a variable, a slack variable, and so you can replace the inequality into equality. So let's say I'll introduce a new one. So I used up to 3. So I call this x4, x5, x6. Each one will be used to take care of each of these inequality. Do we still remember? Right. So you know this is less than equal sign. So all the slack variables, if they become variable, of course they are non-negative, right? Bigger than equal to 0. So if I add x2 to the left-hand side for some quantity non-negative, I could change this into equal sign. Is that right? Do you remember doing that? Okay. So once we have done all that by adding slack variable, so let's say this is problem 1, and then I will get the second set of problem. Now I have a new problem. Okay, so I would first say put into standard form okay, that's what I will do. So the standard form, so first step, the maximizing shall be changed into minimizing, right? That's the standard form. So minimize. Okay, so I just change all the coefficient into the coefficients will carry the opposite sign, the negative of the whole thing, and let's call this the z. Okay, that's our notation. Okay, and then I will add all the slack variables. So the first equation, I will have the following. I'll add an x4. This will equal to 60. And let me copy. And here I add an x5. It's 10. And the last one. X6 equals to 50. Okay, and then of course understood everything, all the variables are non-negative. Is it clear, this step? We can all do it? Everybody okay with this putting into standard form? Okay, so for the simplex method, actually that is not enough because you want it to be in canonical form as well, right? Canonical form is the starting point of the simplex algorithm. But for this example here, take a close look at what we have now. The equations for the constraint, is it already in canonical form by adding the slack variable? Do we think this is in canonical form? If it is, what are the basic variables? So for the first equation, this is 1 with coefficients and 0 in the other, so that's a basic variable, right? And then for the second equation, this one is 1 but 0 everywhere else. That's a basic variable. And then for the third one, this is 1 and that's 0. So the slack variables that we added is actually the basic variables. So let me put that observation down. This is in canonical form. With the basic variable. Would it be okay to introduce this shorthand BV to mean basic variable? I know it's not a standard one to write. Then I'll be in trouble when I want to say basic solution. Then it will be BS. Sorry. Okay, let's say BV, basic variable, just for fun. Okay, so what will be the basic variables? X4, X5, X6. Is that right? So the constraints are in canonical form. Will the basic solution be feasible? How do we check? The sign on the right-hand side. Is that right? Are they all bigger than or equal to 0? Yes, so it gives me a feasible solution. And look at the objective function now. Is it represented only using non-basic variables? The basic variables are x4, x5, x6. All the previous one, x1, x2, x3, are non-basic, right? So these are all non-basic variables. So what does it mean? Is that this new linear programming problem number 2, the whole linear programming problem is in canonical form. Do we agree? So that's a very nice. So 2 is LP, linear programming, in canonical form. Okay, so this is a favorable example that I kind of by accident found a canonical form of the linear programming. Then this can be used as the starting point for the simplex method. Is that clear? So we're going to put that in for the simplex method, okay? So we will be practicing on the Tableau. So we set it up. All right, so let's set this up. X1, X2, X3, X4, X5, X6. And then I have a constant column, the right-hand side of my equation, right? So on the left, I would identify my basic variables is X4, X5, X6. Is that okay? So I'm going to put all the numbers in. So I have 3, 2, 0, 1, 0, 0, 60, -1, 1, 4, that. 2, negative 2, 5, 0, 0, 1, 50. So I draw a line to say that the constraints are finished. Now I'm putting the objective function. And it's 0 to start with. Okay? So if the notation confuses you, you could optionally add a z here to remind yourself that row is for the objective function. Okay? Or if it doesn't, you just leave it blank. It's understood what it is. Okay, now let's see. How can we start our simplex algorithm? So where would I check to see where I should start? I check the coefficients here. Is that right? To find anything that's negative. And I see all three of them are negative. So the algorithm says pick the most negative one. Is that right? And I see, well, I have two of them. They're the same, negative 3. And then the algorithm further say pick the one with smaller index, just a choice. So now, with that, this guy will be chosen. Is that right? Meaning, and this column will be chosen. Is that clear? Okay. And now, what does it mean? It means now x2 should enter as the basic variable, replacing some of them. So which one do I replace? I will be looking at this column. I will be finding if there are any coefficient that's positive, that means I can do the pivoting. If they're all less than or equal to 0, then the solution is unbounded below. Then you stop, right? So here I see that I have two positive coefficients. Then I need to compute the ratio. Is that right? So I would suggest you have, when you do this by hand, you have a last column at the side for yourself to write the ratio. Okay. So the ratio for here, so for this one, I will be computing 60 over 2. I get 30. And then for this, I'll have 10 over 1. I'll get 1. So which is smaller? Is 10 smaller. Is that right? So this guy will be chosen, meaning I will be pivoting right here. So I will bring in x2 into the basic variable and replace x5. Is that clear? Right, so let's put it. So I'll have x4, x2, and x6. x5 will be replaced. Okay. So is it clear how to do this pivoting process? Now you don't see the x's attached to these coefficients. So all you deal with are these coefficients, right? You can take it as a vector. So I take this row vector. I want to make this guy equals to 1. That's the first step. But that's already 1, so which means that this row I can copy. So I have negative 1, 1, 4, and 0, 1, and 0, and 10. That row I just copy. It's ready, right? And in all the other rows, so let me draw a line here, I will have to make all these 0. They had to be 0, they had to be 0, they had to be 0 by this process. Okay. So let's see, how can I make this guy 0? What do? I take this row vector, multiply it by what number, and add on top that this will be 0? Negative 2. Is that right? So multiply by this negative 2 and put on top. So negative 2, 2 plus 3 is 5. Are we okay doing these numbers in our head? A few of them, so that will be 0. Negative 2 gives me negative 8. That's 0, no change. Negative 2, and that's 0. Negative 2 is negative 20. Add on top, I get 40. So is it clear how I got the first row? Would you be able to do it also? Now, the third row, I want to make this guy 0, right? So I multiply the second row by 2 and add on top. Is that right? And then that will be 0. So 2 on that. That actually gives me 0 here also, and I get 0. Multiply by 2, I get 13. And 0, 0 is still 0. Multiply by 2, and this doesn't change. Multiply by 2, I get 70. Is that okay? And I'll do the same thing for the objective function. This is negative 3. To make that 0, I multiply the second row by 3 and add on top. Is that right? Okay? So let's carry out this with some detail. If I multiply this by 3, I get negative 3. Add on top of that, I get negative 5. That will be 0. Multiply by negative 3 is negative 12. And this gives me, wait a second. Multiply by 3, that's 12, minus 3 is 9. And that's 0, not changed. Multiply by 3 gives me 3. And 0, multiply by 3 gives me 30. Okay, so that's one step. Now you generated the second part of the Tableau. Is that clear how this is being carried out? Any questions? Okay? Right. Now how do we proceed? Now we need to check these coefficients again to see if any of them is negative or multiple of them is negative, right? So we see that this guy is negative. So this column will be chosen for me to pivot. And which of these which position should I choose? Do I need to compute the ratio here? I will only choose the strictly bigger than 0 ones, right? There is only 1 here. So this will be chosen. Is that right? Is it clear? Okay. This part you have to be very clear in your head what you have to do. So what does it mean is I will bringing in x1 to replace x4. Okay? So I have x1 here, x2, and x6. Those will be my new basic variables. Okay, so let's perform the pivoting. Okay, so I multiply this row by 1 over 5. So I get 1, 0, negative 8 over 5, 1 over 5, negative 2 over 5, 0, and 8. Is that okay? Is it clear how it's done? All right. And then I need to make this guy 0, right? So I could take this row that I just computed and add on top of it, so this guy will be 0. Okay? Basically, I take the first row, multiply by 1/5, and add on top of the second. Then if you do that, that will be 0, and this is 1, and this will be 4 minus 8 over 5. It gives me 12 over 5, and this will be 1 over 5 on 0, and that will be negative 2 over 5, add on 1, that will be 3 over 5, and that's still 0. And then this was 18, 10 plus 8. Is that clear? Some annoying fractions got in, but can we handle it? It's not too bad? Okay, so the last one, it's already 0, so just copy it, right? So let's do that. So 0, 0, 13, 0, 2, 1, 70. Nothing to do here. Okay, and the objective function, I need to make this 0. So I see this is conveniently the opposite. So I just take the first row and add on top. Is that clear? I make that 0. So I get 0, this 0, adding it. That gives me 1. And this add on top is 1. This add on top is 1. And this on top is 1. 40 plus 30 is 70. Whoops. So, are we happy to see these numbers? you know what matters for you to decide if you should continue the process or not are the coefficients for the objective function. Is that right? Now I see all four of them are positive. So what does that mean? Do I need to continue? Nope. So these are all positive, which means I can stop and I have found the optimal solution. Is it okay? So let's write out. So what can we conclude from this tableau? So the tableau solved the problem 2. Is that right? The one that we, yeah? Hmm? Oh, that's a 0. Yeah, you're right. Is that right? Yeah. I have it 0 and I'm too excited and put 1 there. Yeah. Because you are adding the 0 on that 0. Right? Yeah. Okay, so you can conclude now, at least for the problem, the one we set up that's in the canonical form. So what can we say? So the minimum of z, where do I find that information? Is this corner number, right? But the negative of it is negative 70, attained at, where does it attain that? What is the basic solution for this in this tableau part here? So I know the basic solution will have basic variable x1, x2, and x6. They take these values, and all the others are 0, right? So we can write down. So x1 will be 8, x2 is 18, x3, 0, x4, 0, x5, 0, x6, 7. Is it clear? So this conclusion you can make on the problem 2 that you actually changed a little bit. It's not exactly formulated in the same way as the example at the problem 1 because you added the slack variable. So the final answer in the end to the original problem, well, you have to extract information from here to answer that. Okay? So the original problem is to say maximize. So what would you say? What is the maximum value? The max value equals to what? What is z? Z is the negative of that max value. Is that right? Where z get the mean, the opposite, the negative of z is my max. Is that right? So the max equal to 70. Okay, attain that. Now I only care about x1, x2, and x3, right? The other are slack variables, so I don't really need it. So I could just take the first 3. That's what I need. Okay, so x1 is 8, x2 is 18, x3 is 0. Yeah. So is that clear how this is being carried out? Any questions? All right, so let's make some observations before we move on. What we have learned from this example. So the first observation, we see that to rewrite the linear programming into the standard form in this procedure of adding slack variables with less than equal sign automatically puts the problem in canonical form. Is that right? Now, that's a useful observation. Okay, so let's put that up. So adding slack variables okay, not always, but I say could put the linear programming in canonical form, which is nice. Okay, so let's take a look at where we attain the minimum. You know, the original problem has less than equal sign as the constraint, and you know the solution you eventually get with x1, x2, x3 like that will satisfy the constraint, but sometimes the constraint will be satisfied with equal sign, sometimes it's satisfied with strictly less than equal sign, right? Can we extract that information without plugging this solution in and check the value? Just looking at what we have on the board. And in particular, looking at the solution we got here. So these three numbers here, the slack variable, their value in that basic solution, what does that tell me? So let me write this down. So we see that mean is attained in particular at these slack variable. x5 is, x4 is 0, x5 is 0, and x6 is 70, which is strictly bigger than 0. So what can we say about these signs? What does it mean the slack variable x4 in that solution is 0? That means with that solution, I will have equal sign. Is that clear? And when the slack variable, say, x6 is strictly bigger than 0, here, this is strictly bigger than 0, that means this quantity is strictly smaller than that by 60. Is that right? So at the solution, you will have strictly less than sign. Is that clear? That's something you can read from the solution, right? So this means, the constraint 1 and 2 will be with the equal sign, and the constraint number 3 will be with the strictly less than sign. Okay. Is that okay? Okay, so the third one I want to stress over and over. This is very, very important. That is to begin, even before you start to put it in the Tableau form, you must have a canonical form of the linear programming. Otherwise, you can't start the Tableau. Is that clear? Right, so I want to put that. So Tableau must, okay, it's really important, must start with a linear programming in canonical form. Okay, nothing other than that, otherwise it won't work. Okay, so is that example okay? We have questions? Is it clear? So this is a very favorable example. We put it into standard form. Now it's automatic canonical, and then we set in the Tableau form. We notice that the vector b on the right-hand side is strictly bigger than 0, and it remains strictly bigger than 0 all the way through, which means the problem is non-degenerate, right? And every step you pivot, the objective function is strictly decreasing because it's the negative of that. And then from here to here, it's strictly decreasing also, and in 2 steps, you find the minimum. Okay? That's a very good case. There's no trouble. So we'll take another example where actually you have some trouble with degeneracy, and we don't have any proof for the simplex algorithm when you have degeneracy. But let's just apply the algorithm and see how it works, okay? If it can handle, if it gives me the solution or not. Okay, so I'll take an example. So expect something new to happen here. Okay, let's say I want to minimize the following. Okay, that's Z. Subject to the following. Okay. So you see it's not in standard form. Okay. So of course they're all, that is always there. So let's label these constraints. Right. So this is still pretty much similar to the previous example in the sense that I have less than equal sign, and you know you can add slack variables, right? And from the experience from the previous example, you will know, you will expect that after doing that, I would have it in canonical form. All right? Do we expect it? And then what is nice here is it's already minimizing, so you don't need to change the objective function. Okay? So let's do that. So we already know how to put in standard form, okay, by adding slack variables. So let me put it in. I will put the constraints first, and then I'll put the objective function afterwards. So preparing myself for a Tableau form. So for the first equation, I introduce x5 equal to 50. That's my slack. And then for the second one, so for the second equation, I introduce x6, all right? And the third one, you know the drill. Okay, so that's the constraint, and I will put the objective function down here. So 2x1 plus 4x2 minus 4x3 plus 7x4 equals 2. Let me put 0 plus z, because the 0 will enter the Tableau. Is it okay? And then, same as the previous example, we notice that this is already in canonical form. So make that observation. LP is in canonical form. Okay? With the basic variables, x5, x6, and x7. Is it clear how to check this is in canonical form? Is it clear? We notice that these are the basic variables, and the right-hand side is all non-negative, right? And the objective function is expressed using only the non-basic variables. All right? Question?
If you're adding slack variables like that, when would there be a case that it wouldn't end up in canonical form?
Oh, let's say I have this bigger than equal sign. Then you have to put negative, and that is not canonical form. Is it clear? Or you could have the first equation already equal, And then you only add slack onto these two, or let's keep the first one, okay? Let's say the last one is an equal constraint. Then you cannot add x7, then it's not canonical. It's not obvious. This is a lucky situation, all right? Later we'll learn a way of dealing with it. Okay, so right now we're fortunate, so let's be happy with this. Okay, let's set it up in the Tableau form. Okay, so I have to write in very lined up and straight form. So, okay, x1, x2, x3. I have so many. I have all the way to x7, x4, x5, x6, x7, and then I have the constant term. All right? I don't need it to be so long then. Okay, and then I know my first set of basic variable, x5, x6, x7. Okay, and then I will put in the numbers. So let me just copy the numbers without messing up. 8, -2, 1, -1, 50, 3, 5, 0, 2, 150, 1, -1, 2, -4, and 2, 4, -4, 7. That's all 0, and that's 0. Okay. So this is the initial Tableau, which is just a problem in a canonical form. And now we're going to start our simplex algorithm. Okay, so where do I start? Can someone guide me through this? So is this already an optimal situation? Nope. What gives away? This negative, right? Okay, so I need to choose this column, right? So what do? I need to compute what? The ratios. Is that right? I'll just write it at the side. Okay, so for which numbers do I need to compute the ratio? For this one, 50 over 1 gives me 50. Do I need to compute the ratio for this one? No, it's 0, right? So I don't need. And then for this one, 100 over 2 is 50. Now what do? I check which one is smaller. Is that right? I find the minimum of it, which is the same, meaning they both take the same value. So what did the algorithm say? Which one should I pick? Remember we summarized? We picked the one with the smaller index, which means pick the one on the top, the higher one, right? Here. So I will be picking this as my minimum. Is that right? So which means I would pivot right here. Okay? Pretend we're a computer, we just accept orders. Okay? We'll get to the computer part. Okay. So the choice here means that x3 enters and we'll be replacing x5. Is that clear? So let's write down the basic variable x3, x6, and x7. Okay? We'll just carry this out by hand so we know clearly what we have to do here. Okay? So now this is already 1, so I just copy down the first row without changing anything, because I usually have to multiply by the reciprocal of that. And then for the second row, I am also lucky that this is already 0, so I just copy. Is that clear? I don't need to do anything. It's already 0. So copy 3, 5, 0, 2, 0, 1, 0, 1, 5, 0. And the third row, that's not 0. I have to get rid of that 2 and make it 0. What can I do? I take the first row, multiply with what? And then add on top the negative of the ratio. Is that right? -2. Okay? So if I do that, what do I have? I multiply by -2, -16, it gives me -15, and then that's 4, it's a 3, so it's a 0. This becomes 2, and I get -2, multiply by -2, that's 0, and that doesn't change. And I multiply this by -2, I get -100, add on top of 100, I get 0. Is that clear how I did that row? Okay, it's repetitive, right? Okay, and then the objective function, I need to make this guy 0. So I multiply the first row by 4 and add on top. Is that clear what I do? You can carry this out by yourself and see what you get. Multiply this by 4, 32, I get 34, -8, -4, 0. 4 is -4, that's 3. Multiply by 4, I get 4. And then it's 0, 0, it doesn't change. By 4, I get 200. Okay, so you see, after taking this step, the minimum value is reduced from 0 to -200, right? I get much smaller. And then something interesting happened there. I actually now get a 0 on the right-hand side for the B. Okay, we'll see what that does to us. This tells us that it's degenerate, right? And our theorem actually does not cover this case. But let's continue with the algorithm. Okay, so the algorithm continues, and we found a negative coefficient is -4. And then I check this row. I computed the ratio. 150 over 5 is 30, and 0 over 3 is 0. Do I need to compute for the first row? No, because that's negative, right? Okay. So among these two, I know that's smaller. So this will be chosen. Is that clear? The decision which column, which row will be chosen, that's the important decision. Once you made that choice, the rest is a standard procedure to carry this out, right? Okay, so are we comfortable with this pivoting? May I just write out what I will have after I decided to pivot right here, replacing x7 with x2? Okay, so I will have x3, x6, and x2 now as my basic variable. Okay, may I just write out the result? Is okay? Let's see. So I have -2, 0, 1, -7 over 3, -1 over 3, 0, 2 over 3, 50, 28, 0, 0, 16 over 3, 10 over 3, 1, -5 over 3, 1, 5, 0. These are numbers. Let me copy this down. You are welcome to try it as we go on and see if I make any mistakes. So that's the constraint, and then the objective function is changed into 14, 0, 0, 1/3, 4 over 3, 0, 4 over 3, and 200. Okay. So that's the third tableau that I have. Are we happy to see these numbers here? No negative signs, right? In the row for the objective function, all the coefficients are bigger than or equal to 0. So do I need to continue? Nope, I can stop. Is that right? It's done. I have reached the minimum. Is that clear? How do I know I can stop? Is it clear? All right, so let's conclude. So what can we conclude now? The Z min, what would that equal to? Well, this number, negative 200, attained at what values is it attained? Will we be able to write it out directly just for x1, x2, x3, and x4? Or do you want to take a step? Write it out for this one first and then translate it over. You know, you only care about x1, x2, x3, x4. Is that right? Is any of them in the basic variable set? Yes, you know x2 and x3, they will take these two values and all the others will be 0. Is that right? Can we just write it out? So what will be x1? Someone want to tell me? Is it the basic variable? Oh no, it's not, right? And x2, I will find it here, 0. And x3 is a basic one. It takes value 50. What about x4? Is it a basic variable? Nope. And it's 0. So, so any questions about this procedure, how this is being carried out? We okay? Would you be able to do a similar thing? You have a couple of homework problems that I specifically wrote. You do it by hand, not by the software that we will introduce very soon. Okay? Show me you can carry this out by hand. All right? Okay, so there's the procedure. Okay. So I want to catch your attention. Actually, I mentioned here, we see that now I have a 0 on the right-hand side for the b value. We know we call this is a degenerate case. My linear programming problem actually is degenerate. And you see that because it's 0 on the right-hand side, and when we perform one step of pivoting by switching this x2 replacing x7 in the basic variable set, what we found in the z value is the same. Do we see that? We actually did not reduce the z value at all. We have found the same z value, but what's good is at this z value here with this basic function, it clearly tells me that this is a minimum. Is that clear? So degenerate, so we make this observation. If this is degenerate, and when you do this step, then objective function remains the same value, or takes the same value after this step. Okay, just want to catch your attention. So even though this is degenerate, and we see that the simplex method works just fine, and after 1-2 steps, we reached the point that we can apply theorem O, the optimality condition, and we see that we can stop. Okay, even though, theoretically we cannot prove for degenerate case, because it could happen that you move from one point to the other, z is not changing, and if you're unfortunate, here you still have negative coefficient, and the coefficient will tell you to go back to a previous one, then you end up in a circle. All right? So in the textbook, there is an example. In the appendix, you can pull it out and play with it if you are curious. Okay. And then another comment I want to make here is that there is some ambiguity in this algorithm. Actually, you might already have suspicion at the first step. We have two choices here. The minimum is attained for two different indices. So we made a choice of choosing the first one. You could as well choose the second, which would be fine. All right? But for an algorithm, a computer needs clear direction what to do. So that's what the algorithm is being set. And then later on, we'll see how it performs if we choose the other one. Okay? It has no problem at all. Okay. So, any questions on this? Yeah?
What if the 3 is equal to negative 3, so we don't consider the x7 equal to 0?
Which one?
The line of pivot.
What if this is negative?
Yeah.
Then you don't consider it. No, then you would be picking that. Yeah.
So that will give us another answer. This is,
Yeah, but right now it's 3, right? So when you pivot, look at the column, only check those with positive coefficients. If it's 0 or negative, that will not give you any constraint. You will not use those at all. Okay? And if all of them shall be negative, and then you know the minimum is unbounded, and then you stop also. Is that clear?
So it's nothing about the degenerate form. Like if it is degenerate, there is like a certain type of answer.
If it's degenerate, if this is negative, you still don't consider it. It will never be your choice. Yeah. Okay? Because I encourage you to write it out and think about it. Why? All right? Mm-hmm. If you're curious. Yeah. Okay, so now, good news for us. We're going to introduce some help. So looking back into our computation for these two examples, we realized the following. What we do need, the intelligent step for us to choose is, once the tableau is given, I need to make a decision of where I put this circle, where I do the pivot, right? Which column, which row, what position will be the one I use. Okay. And, okay, so this is done by you. You look at where I have the negative one, and then I check here, and the additional information you needed, which I put at the side, will be the ratio. These you would need also. That can help you make the decision, right? Once you have that, you make the decision, you say, I pivot there, and the computation of the next part of the tableau is a very standard procedure. Do we agree? So that part is actually quite time-consuming, and it's repetitive. It's just the same thing you have to do. Okay, so we could get help to perform that step. Okay, so I will introduce you a little applet, and we'll see how to use it. So, okay, so let me turn it on. All right. Okay, so did everyone get the email I sent out last night about where to download? Let me turn off some lights. Chalkboard. Chalkboard. Should I remove the light in the front? Would that be okay for us to see? Okay, you can log on onto your computer if you want, and go to that link that I gave in the email. I think I sent an email to everyone, right? And you click on that, and you will be at this page. And if you just click download, you will download this little app. It's a JavaScript, okay? And once it's downloaded and you open it, are we there? And this is what will pop up when you open that script. Can we all see what's on the blackboard? Okay, so let me move this up. Are we all there? Not yet. Did we find the web? Okay. If you don't know the web, it's here. You can copy this bar. Or you can Google LP assistant, and the first choice will be the one. Are we there? Anyone who's not there? Should I wait? And then you download it, and then you open it, and this is, okay, you will have untitled problem 1. I have 2 because I tried 1 already, just to check if it works on this computer, all right? So you will have untitled problem 1 there. So are we all here? Let me know. Are we okay? So I'll show you how to use it. Let's use the example 2 that we just did, okay? So when you open it, by default, it will be in this edit mode. So don't touch it, leave it in edit mode. And by default, it gives you 3 variables, x1 to 3, and 2 constraints, okay? And in our problem, the one we just did, we actually have 7 variables and 3 constraints. So we need to add more. So we can go to this Tableau. Can everybody click on that? Add regular variable. You click it once, you get 1 more variable. It's automatically labeled. Is that clear? And you keep adding until we have 7 of them. So let me do that. You can do together with me. And if I'm too fast, let me know. We'll slow down. So now I have 7 variables. Are we okay? And we have 3 constraints, right? So let's add. Add a constraint. So I have 3. Now the table is what I need. Are we okay? Is everybody with me where to find that add? Okay. And now I need to specify which of these are my basic variables. So in my problem, I know that the first basic variable, if you just click on that X, you have all these choices. I know the first basic variable was x5, and I select it. Is that clear? All right. And then the second one was x6, and I select it. Okay. And the third one was x7. So I selected all the basic variables. Is that clear? Okay. All right. Now I will have to fill in the table. It's by default all 0, so you just fill in the non-zero numbers. So let's fill it in. First is 8, -2, 1, -1, 1, 0, 0. The right-hand side, 50. So I just fill the first row. Are we okay? Let me know if you're in pace with me. So second row, 3, 5, 0, 2, 0, 1, 150. So I fill the second row. Are we okay? And the third one, I have 1, -1, 2, -4, 0, 0, 1, 100. All right. And the objective function, the last row is 2, 4, -4, and 7, and 0. So I'm done. Are we all done? Did we fill the table? All right. Now we set up the problem. Now we are ready to perform the pivoting process. So go to the mode here. Now click the little circle in front of pivot. Now it's ready for you. Did we all do that? Now you're in pivoting mode. Okay. So the next step, okay, let me make this a bit bigger so I can see my table. Make it a bit bigger because I know I need a bit more. So now the next step is your choice. So you see I have a -4 here, so I need to consider this column. Is that right? Column number 3. So I need to know the ratios between the right-hand side and this coefficient when the coefficient is positive. So do you spot something that can help you? Anyone sharp eyesight? Look to the left corner down here that says ratio. And if you move your cursor over this 1, it gives you that ratio. Do you see that? And then you move to 2, it gives you that ratio. So the only challenge for you, okay, we are not Dory. We don't have short-term memory loss, right? You saw a 50, you move to another one, you see a 50. Can you remember a set of 3, 4 numbers and remember which one is the minimum? If you can do that, you're good. So I see that 50 and 50, they're the same, so either one will work, right? So I picked the one on the top. So now here's the magic. So move your cursor onto that number with the smaller ratio and give it a click. Do you get what I get? You get the next part of the Tableau. Not only did it compute all that, it also changes the indication of what are the new basic variables. Isn't that cool? Life is so much easier, isn't that right? You just need to click. You just need to know where to click. So is that clear? And now, I have -4. I need to continue, right? So I spot that this is still negative. So I need to look at the ratio over the positive ones. So this one gives me 30. I mentally remember I have a 30 here. That one gives me 0. So that's smaller. Can we all click on 3, or you already did? Click on 3. And it does the next step for you. And it also changes the basic variable on the left. It tells you now what they are. Isn't that nice? And now you look at all the coefficients here. They're all positive, and then you stop. So 3 clicks, and all the work I did on the board. So is it clear how to use it? All right. I do want to say, so in your homework, there are a couple of problems I want you to do by hand. You write down the Tableau, you go through this process and make sure you can do it, all right? And the last problem, I ask you to do it with the LP assistants, and then you turn this on and you do it with the LP assistant. And then you have to show this final form, print it out, or whatever, attached to your homework. I need to see what you did there. Is that clear? So I don't know what computer you have. There is an option here. If you click this problem here, there is a choice for you to print that one. And there is also a choice for you to save as. You can save it there, so next time you can open the same problems and play with it again. Is that clear? So if you click print, depending on what computer you have, you could have the choice of printing it or save it as a PDF, and depends on what type of homework upload you choose. If you do LaTeX typeset, you can attach the PDF in your typeset file. If you handwrite it, then you should print it out and attach with your homework. Is that clear? And if you have trouble finding out how to print it or how to save it, I mean, in the worst case, do we all know how to take a screenshot? You can always do that. Take a screenshot and print it or attach it or whatever. Is that clear? Okay. And now, one thing could happen that during the process, oops, you clicked at the wrong spot. What do? You want to reverse. You want to go back. Let's say for this problem, for example, I would be curious that instead of pivoting at this, what if I choose that? I want to play around with this algorithm. And you can easily do that. You can go to, click on the Tableau. The last thing says remove the last Tableau. Try that. If you do that, it removes the last step you did. You can regret and you can start over, right? All right, and then I can continue. I remove it again. So I'm at the beginning. Is that clear? Now, okay, so I see that this guy here in the column 3, the first row and the third row, they both give me 50, which both could qualify as my candidate to pivot. Let's say if I shall click on the third row and third column, do you dare to click? Click on it, and we get that. Do we all get that? And now I can continue, because now I see I still have a negative term here, and I can choose between the first and the second to further continue. So for the first one, I get 0. The second one, I get 75. Okay, no question, I'll pick the first. Is that clear? And now I have this tableau in the end, and I see that I can stop because all of these are non-negative. Do we see? Did we get all that? Okay, so what is that telling me? What is that solution? Is it the same as the one I got by click the 1 instead of the number 2? So can you write out the conclusion for the tableau that we have right now? So let me try to write out. So what would that be? The solution will be, the z minimum will be negative 200. Is that what we got with the other way? Attained at what? So at, let's just write out x1, x2, x3, x4, because those are the real variables, right? So x1 is not here, so it shall be 0, right? x2 is 0, right? x3 shall be 50, and x4 shall be 0. So 0, 0, 50, 0. Isn't that the same one? So it leads you to the same conclusion, right? That's, they say, every road go to Rome. So we get there. So any questions? Is it clear how this is being used? Okay. So I think that's, oh, one thing I forgot to say, guys. I forgot to mention one thing here. So this display here, you can choose to display it as either a fraction, which is being chosen now. That's why you see all these fractions. Or you can say, I wanted to have 1 decimal place being displaced, or 2, or 3. This is up to you to choose, okay? So on this computer, it opens up into something that's already a pretty big font, but when I have it on my computer, it actually gives me very small font. Or you think this font is too big, that you don't like it, then you can use this useful aid. If you click on that, there is a font and size selection. If you click on that, and then you get this tiny little thing on the corner that you can choose which font you want and which size you want. Right, so let's try some font. Is that an okay font? I choose size 9, and I click apply, and then you get some different fonts. Pick the one that you like most. Okay, and let's see if I choose the display like this, and you see it's in decimal. It takes the first decimal place, all right? And then do that, you get the 2 decimal points, and that you get 3 decimal points. So you have all these options there for you. Is that clear? I think it's pretty user-friendly, right? It's pretty obvious what you have to do. Well, if you know the right place to click, and then it's very quick. It will solve this problem for you in a few seconds. Well, okay, a couple of minutes, let's say. You have to type everything in. All right? All right. So any questions? Okay, so your next homework is already on Canvas. One problem you do with the LP assistant, and the other you do by hand. You have to show you can do both. All right? All right, okay, then see you next time.